Mercury is the closest planet to the Sun, yet it remains one of the most mysterious. For centuries, we observed it from Earth, but never truly understood it. Why does such a small planet have such a powerful magnetic field? And why are there signs of ice on its surface despite the extreme heat? Mercury is the fastest planet in our solar system. It completes a full orbit around the Sun in just 88 Earth days. But it rotates slowly. One Mercury day lasts 59 Earth days. This creates a strange effect. You could see the Sun rise twice in one day. During the day, Mercury's surface heats up to 430 degrees Celsius. At night, it drops below -180 degrees Celsius, a dramatic swing due to the lack of atmosphere. No other planet experiences such extreme temperature changes. This makes Mercury harsh, yet perfect for studying airless environments. Mercury has almost no atmosphere. Its gravity is too weak to hold gases against the force of the solar wind. Instead, it is a thin exosphere, a shell of atoms knocked off the surface. That means no sound can travel there. Complete silence. Beneath Mercury's surface lies a giant metallic core. It makes up nearly 85% of the planet's radius, more than any other planet. Scientists believe this core is partially molten and generates a magnetic field. But why is it so massive? Theories point to a long-lost cosmic catastrophe. Scientists believe that Mercury once collided with a massive celestial body. This event could have stripped away much of its mantle, leaving behind a huge metallic core. Such a hypothesis explains the planet's unusual density. It may have been one of the earliest and most violent catastrophes in the solar system. Despite its small size, Mercury has a real magnetic field. It's about 100 times weaker than Earth's, but still active and generated from within. This surprises scientists, especially since Mercury lacks a thick atmosphere. A partially molten core is likely responsible for this invisible force. From orbit, Mercury appears as a scorched, crater-covered sphere. It resembles the Moon, but with metallic glints on its surface. Countless impacts created massive craters and ejecta rings. Each crater is a silent witness to ancient cosmic collisions. One of Mercury's largest craters is the Caloris Basin. It was formed over 3.5 billion years ago by a colossal asteroid. Its diameter spans more than 1,500 kilometers. Around it lie rings of faults and ridges, like waves frozen in rock. Unlike Earth, Mercury doesn't have tectonic plates. Yet, its surface is filled with folds and cracks. As the planet cooled, it shrank slightly, causing the crust to wrinkle. These wrinkles are called scarps and stretch across the surface. Mercury is the closest planet to the Sun, only 58 million kilometers away. It receives 7 times more solar energy than Earth. But the heat doesn't linger since there's almost no atmosphere. The sunlit side heats up instantly under the blazing light. At Mercury's poles, deep craters never see sunlight. Within these eternal shadows, scientists found signs of ice. How it got there remains a mystery. Perhaps comets or asteroids delivered water billions of years ago. Many scientists think comets helped spread water through the solar system. Comets are icy bodies traveling at immense speeds. If one struck Mercury, water could have stayed in its shadowy craters. This is one of the leading theories about the origin of water on planets. In 1974, Mariner 10 became the first spacecraft to visit Mercury. It sent back images showing a cratered surface much like the Moon. It also discovered Mercury's magnetic field and lack of atmosphere. This mission marked the beginning of serious exploration. In 2011, NASA's Messenger entered orbit around Mercury. For 4 years, it studied the planet's geology, chemistry, and structure. Messenger discovered ice, mapped terrain, and took thousands of images. Its findings forever changed our understanding of Mercury. Reaching Mercury requires a series of gravity-assisted maneuvers. Because of the sun's pull, you can't just fly straight to it. spacecraft swing past Earth and Venus, gradually losing speed. Only then can they enter orbit around Mercury. Mercury is surrounded by a thin dust cloud created by micrometeoroids. Each impact blasts tiny particles off the surface. This dust reflects light and contributes to Mercury's faint exosphere. Though nearly invisible, it plays a key role in surface processes. Gravity on Mercury is only 38% of Earth's. A human would weigh nearly 3 times less there. But Mercury's orbit is unstable due to the Sun's influence. In fact, it helped confirm Einstein's theory of general relativity. Scientists noticed Mercury's orbit shifts slightly over time. Newton's laws couldn't fully explain this motion. Einstein's theory of relativity provided the answer. Space itself was curving. Mercury became the first proof of warped spacetime. Mercury's core isn't just large, it's layered. There's a solid inner core, a liquid outer shell, and possibly a sulfur-rich layer. Think of it as a multi-layered metallic cake. This structure explains many of Mercury's magnetic and thermal mysteries. Mercury is covered in deep cracks and ridges. They're the result of the planet's interior cooling and shrinking. Some of these faults stretch for hundreds of kilometers. They are silent reminders of Mercury's aging body. One day on Mercury lasts almost 59 Earth days. The sun rises and sets incredibly slowly. Such long days cause extreme temperature swings. Mercury lives on a very different clock. Because of the way Mercury rotates and orbits, a strange event occurs. The sun can rise, set, and then rise again on the same day. This phenomenon is unique in the entire solar system. Even Mercury's sunrises defy expectations. Unlike most planets, Mercury has no moons. It also lacks rings like Saturn or Uranus. This makes it a lonely traveler near the sun. The empty sky above it emphasizes its isolation. Mercury is one of the densest planets in the solar system. Despite its small size, it contains an enormous amount of mass. The reason lies in its large metallic core. This makes it a truly unique object for study. Scientists sometimes model how Mercury would look with an atmosphere. A thick atmosphere might reduce the extreme temperature swings. Clouds, haze, maybe even climate patterns, it would be a different world. But Mercury remains dry, silent, and bare. Mercury combines burning heat and freezing cold. This is due to its lack of atmosphere and closeness to the sun. It feels torn between light and darkness. Surviving here would be nearly impossible. Several space agencies are planning new missions to Mercury. Their goals include studying its surface, core, and polar ice. The aim is to uncover the planet's deepest secrets. Mercury is still waiting to be fully understood. The Bepi-Colombo mission is a joint project from Europe and Japan. The probe is following a complex path with gravity assists. It's expected to enter Mercury's orbit in the coming years. This will be the most in-depth study of the planet to date. Reaching Mercury's orbit is one of the hardest challenges in spaceflight. The sun's gravity pulls strongly, demanding extreme precision. Bepi-Colombo must slow down at just the right moment. Years of planning go into this single maneuver. Modern probes are looking for signs of Mercury's ancient history. Craters, cracks, and minerals all hold clues from the past. Every inch of terrain holds a story. It's like reading a cosmic history carved in stone. Geological layers on Mercury reveal volcanic flows and ancient impacts. Some areas resemble solidified lava fields. Between the layers are the boundaries of different eras. They are the key to understanding the planet's interior. Billions of years ago, volcanoes erupted across Mercury. They spread lava over wide plains, smoothing the terrain. Today, these volcanic fields remain mostly unchanged. They are frozen moments from the planet's fiery past. Absolute silence rules on Mercury. There is no wind, no rain, no sound, only stillness. It's the perfect place for observation, yet deeply lonely. The entire planet feels like a stage without actors. Mercury rotates in a special resonance, 3 spins for every 2 orbits. This means the same side faces the Sun for long periods. It's called spin-orbit resonance. It shapes the planet's light, heat, and time. Sunset on Mercury is a unique event. The Sun sinks below the horizon very slowly. Temperatures drop quickly, and freezing darkness follows. The transition from fire to ice is almost instant. Mercury's north pole lies in eternal shadow. Deep craters there have never seen sunlight. Yet scientists found ice in one of the hottest places in the solar system. A paradox that still puzzles researchers. Mercury is covered in craters of all sizes. Scientists have mapped tens of thousands of them. Each one has a name, an age, and a history. It's a library of impacts written across the land. Without an atmosphere, Mercury's surface is exposed to solar wind. Charged particles constantly bombard its soil. They knock atoms into space, creating the exosphere. The planet is slowly eroded by sunlight itself. Every crater, crack, and slope on Mercury tells a story. It holds the scars of billions of years of cosmic time. No water, wind, or erosion exists to erase the past. This planet is the oldest page in our solar system's history. Mercury's surface is made of dense, rocky materials. Under a microscope, it reveals tiny cracks, grains, and mineral structures. There are traces of sulfur, magnesium, and iron in the dusty soil. This complex chemistry tells the story of a planet baked by the Sun. Mercury's orbit is the most elliptical of all the planets. Its speed and path are influenced strongly by the Sun's massive gravity. At times, it moves faster than any other planet. These orbital quirks helped prove Einstein's theory of relativity. Without an atmosphere, Mercury is constantly bombarded by cosmic rays. High-energy particles strike its surface directly, altering its chemical makeup. These invisible forces gradually shape the planet's outer layer. It's a slow but relentless transformation. The long ridges and scarps on Mercury's surface are tectonic in origin. They formed as the planet cooled and contracted over billions of years. These features stretch for hundreds of kilometers. They are physical evidence of a shrinking world. Imagine looking at Mercury through the window of a spacecraft. You'd see endless craters, long shadows, and silent plains. No clouds, no wind, just sunlight and rock. It's like flying over a fossil of the early solar system. Mercury's surface is made of dense, rocky materials. Under a microscope, it reveals tiny cracks, grains, and mineral structures. There are traces of sulfur, magnesium, and iron in the dusty soil. This complex chemistry tells the story of a planet baked by the Sun. Mercury's orbit is the most elliptical of all the planets. Its speed and path are influenced strongly by the Sun's massive gravity. At times, it moves faster than any other planet. These orbital quirks helped prove Einstein's theory of relativity. Without an atmosphere, Mercury is constantly bombarded by cosmic rays. High-energy particles strike its surface directly, altering its chemical makeup. These invisible forces gradually shape the planet's outer layer. It's a slow but relentless transformation. The long ridges and scarps on Mercury's surface are tectonic in origin. They formed as the planet cooled and contracted over billions of years. These features stretch for hundreds of kilometers. They are physical evidence of a shrinking world. Imagine looking at Mercury through the window of a spacecraft. You'd see endless craters, long shadows, and silent plains. No clouds, no wind, just sunlight and rock. It's like flying over a fossil of the early solar system. Mercury's surface dust, called regolith, holds a unique chemical signature. It contains sulfur, potassium, and even trace elements not found elsewhere. These clues help scientists understand the planet's formation. Every grain is a tiny time capsule. Mercury has barely changed in billions of years. Its surface holds scars from the earliest days of the solar system. Without wind or water, nothing erases those marks. It's like a museum of cosmic history. Long ago, the sun was younger and slightly dimmer. Mercury orbited it just as closely then as now. But its surface was still scorched, battered, and shaped by ancient forces. That same terrain remains today, almost untouched. At first glance, Mercury looks like the Moon. Both are gray, cratered, and airless. But Mercury is denser, richer in metals, and closer to the Sun. Their similarities are skin-deep. Inside, they're worlds apart. One day, a robotic lander might touch down on Mercury's soil. It would need to survive extreme heat and powerful solar radiation. Solar panels would power its instruments in short, brutal daylight hours. It could unlock secrets hidden for billions of years. Mercury remains one of the least explored planets in the solar system. Yet it holds answers to our biggest cosmic questions. How did rocky planets form? What shaped our solar system's birth? In Mercury's silence, the story still waits to be told.
What if our entire history about Mars is a mistake? For centuries, we believed in a myth we created ourselves. A red dot in the sky always raised questions. People wondered, could it be another living planet? In ancient Rome, it was named after the god of war, Mars. Its color seemed bloody and dangerous. Everything changed with the invention of telescopes. Astronomers saw strange lines on Mars. These lines were mistaken for canals, as if someone had built them. A real Martian fever began. Astronomer Lowell claimed Martians were saving their dying planet. He believed they were pumping water from the poles. The world went crazy over aliens. Newspapers wrote that we were not alone in the universe. But in 1965, the Mariner 4 probe shattered the dream. It sent back images of a dead, lifeless planet. No canals, no cities, just craters, dust, and silence. The illusion collapsed, but a new race had begun. Now we didn't want to meet Martians, we wanted to get there ourselves. In 1971, the USSR launched the first spacecraft into Mars orbit. It was called Mars 2 and became the first orbital mission. Mars 2 attempted to land a capsule but failed. It entered the atmosphere at the wrong angle and crashed. Later, the US responded with Mariner 9. It was the first to successfully orbit and send back images. When Mariner 9 arrived, the whole planet was in a dust storm. It waited weeks for the winds to calm. When the dust cleared, cameras revealed mountains and canyons. Mars was far more complex than anyone thought. In 1976, NASA sent two landers, Viking 1 and Viking 2. They were the first to land softly and search for life. One experiment showed possible signs of metabolism, but the results were inconclusive and remain debated. Since then, searching for life has been the main goal of every mission. Mars was no longer a myth, it became a scientific mystery. In 1997, the first rover arrived, Sojourner. It was tiny but revolutionized the study of the planet. These photos showed Mars up close. Rocks, dust, wheel tracks, everything looked real. In 2004, two new rovers landed on Mars. They were named Spirit and Opportunity. They were meant to last just 90 days, but they worked for years, sending back valuable data. Spirit got stuck in sand and couldn't move, but it kept sending signals to the very end. Opportunity traveled more than 45 kilometers across Mars. It set a record for the longest rover journey. In 2019, a storm disabled the rover. Its last words were, "My battery is low, and it's getting dark." In 2012, Curiosity landed, a full laboratory on wheels. Its landing was the most complex in history. Curiosity found evidence of ancient lakes. Mars once had liquid water. In 2021 came Perseverance, the most advanced rover ever. It's exploring a crater that once held a lake. Along with it arrived Ingenuity, a tiny Mars helicopter. It became the first to fly in another planet's atmosphere. Now, we can not only drive, but fly across Mars. And this is only the beginning of a new chapter in exploration. NASA has long dreamed of returning samples from Mars. Now, that mission is finally in development. Mars rovers have limits. To fully understand its past, we need Martian soil on Earth. Perseverance landed in Jezero crater, a dry river delta. This site once held water billions of years ago. Sediment layers in the crater may hold ancient life signatures. It's one of the best places to look for biosignatures. Perseverance is collecting core samples and sealing them. These tubes will one day be picked up and sent home. Ingenuity's flights proved controlled flight is possible on Mars. Its technology may be used in future aerial scouts. From above, the helicopter captures stunning terrain images. It scouts paths for the rover to follow. Mars gets its red color from iron oxide in the soil. It's literally rusting over millions of years. Mars has no global magnetic field to block radiation. Future astronauts will need serious protection. The atmosphere on Mars is 100 times thinner than Earth's. It's made mostly of carbon dioxide. Dust storms on Mars can cover the entire planet. They last for weeks and block sunlight. Average surface temperature on Mars is minus 60 degrees Celsius. At night, it can drop to minus 100. Simple weight comparison. Human silhouette on Mars with scale reading 38 kilograms, side by side with Earth at 100 kilograms. Clean scientific layout. Everything must be ultra-realistic, without glitches or unnatural movements. Mars has ice at its poles and beneath the surface. One day, this water may sustain a colony. Mars has two tiny moons, Phobos and Deimos. They look like captured asteroids. Because of signal delay, landers operate on their own. There's no way to control them in real time from Earth. Engineers call it 7 minutes of terror. That's how long descent lasts, with no room for error. Mars is home to the tallest volcano in the solar system, Olympus Mons. It's nearly 3 times the height of Mount Everest. Gales Marineris is the largest canyon in the solar system. It stretches over 4,000 kilometers. Could we one day terraform Mars? Scientists debate the possibility of transforming its climate. Elon Musk wants to build a city on Mars. He believes humans must become multiplanetary. Starship is being designed for interplanetary travel. Its goal, deliver cargo and people to Mars. Mars habitats must protect from radiation and cold. Underground or domed shelters are being studied. Can we grow food on Mars? Scientists are testing crops in simulated Martian soil. NASA and private companies plan to send humans in the 2030s. It could be the most dangerous mission ever attempted. Mars suits must be flexible, pressurized, and dust-proof. Prototypes are already being tested on Earth. A Mars mission may last years, and there's no quick return. Some even call it a one-way trip. Mars challenges our science, our courage, and our imagination. And someday, it might just be our second home. The race to Mars isn't just scientific, it's also political. Nations want to be the first to establish presence on another planet. China and Europe are developing their own Mars missions. The global interest in Mars is growing rapidly. Mars once had a magnetic field like Earth, but it disappeared billions of years ago, leaving the planet exposed. Without that protection, the solar wind stripped away most of the Martian atmosphere. This changed the planet forever. Some scientists believe Mars once looked like earlier, with rivers, lakes, and possibly even oceans. Evidence suggests that water flowed on Mars for millions of years, but the planet slowly lost its ability to retain it. NASA's MAVEN mission studies how Mars lost its atmosphere. It found that solar wind is still eroding the planet today. Today, Mars is a frozen desert, but traces of its wet past are everywhere. NASA's MAVEN mission studies how Mars lost its atmosphere. It found that solar wind is still eroding the planet today. Mars may be lifeless now, but it teaches us about habitability. It could help us find life elsewhere in the universe. Future missions aim to dig deeper into the Martian soil, searching for fossilized microbes or underground water. Subsurface ice could be key to future colonists. It's a vital resource for survival. Mars is a perfect testbed for autonomous robotics. Rovers must think for themselves millions of kilometers away. Artificial intelligence helps navigate the terrain. It avoids obstacles and chooses the best path. If we succeed on Mars, we may go further, to moons like Europa or Titan, even beyond the solar system. Mars inspires a new generation of scientists and explorers. Kids today could walk there tomorrow. Colonizing Mars requires teamwork on a global scale. No single country can do it alone. Building a Mars base is like constructing a space station, but on land. It must be self-sufficient and secure. Mars time is different. A day is 24 hours and 39 minutes. Colonists will need to adjust to the Martian soul. Nuclear energy might provide a backup. Compact reactors are already being tested. Communication with Earth has a delay of up to 22 minutes. Mars missions must rely on autonomy and planning. Psychological health is a major challenge. Crews will face isolation, confinement, and time delay. Virtual reality and robotics may help bridge that gap, letting astronauts feel more connected. Art, music, and culture will travel to Mars too. A new society will need more than just survival. Will we preserve Mars or reshape it for ourselves? Ethical questions will define our choices. Some argue we shouldn't touch Mars at all, that we should protect it as a pristine world. Others believe transforming Mars is our destiny, a way to extend life beyond Earth. Others believe transforming Mars is our destiny, a way to extend life beyond Earth. The first child born on Mars could arrive this century, a human not of Earth, but of two worlds. Mars is far, over 50 million kilometers at its closest, and yet, it feels closer every year. Our robots are already there. Our footprints are next. Mars is silent, cold, and empty, but it calls to us louder than ever. Maybe we go to Mars not because it's easy, but because it's hard. That challenge defines us. From ancient myths to modern rockets, we've chased this red world for centuries, and we're not stopping now. Now we stand at the edge of a new era, the era of becoming interplanetary. Mars forces us to ask, what kind of explorers are we? Brave, curious, or careful? Whatever the answer, Mars is waiting, and we're almost ready. Whatever the answer, Mars is waiting, and we're almost ready. And one day, when someone looks up from the surface of Mars, they'll see Earth as a pale blue dot in the sky.
What if danger to our galaxy is already near? There are objects in the universe that can destroy stars and even entire worlds. And we still don't fully understand how they work. Each one could change the fate of the Milky Way. Ready? The first threat is black holes. They don't just suck in matter, they distort space and time itself. Some are city-sized but heavier than a star. Get too close and there's no way back, ever. A monster hides at the center of our galaxy, a supermassive black hole. It's 4 million times heavier than our sun. Thankfully, it's asleep for now. But one day, it could awaken. Imagine that. Next threat, gamma ray bursts, the most powerful explosions in the universe, triggered by dying stars. One burst could evaporate a planet's atmosphere in seconds. If it points at us, we have no chance, none. Gamma ray bursts are visible billions of light years away. They unleash more energy than anything humans could ever create. Scientists track them like wild beasts. But predicting them is nearly impossible. Dangerous. The third threat, rogue planets, loners ejected from their star systems. They race through the galaxy in total darkness. One day, they could crash into us without warning. Some of these planets are the size of Jupiter. They move silently, invisible to normal telescopes. Scientists have already detected dozens of such objects. But that's just a fraction. Terrifying. If such a planet passes too close, its gravity will disrupt orbits. That would trigger chaos in the solar system. Planets could collide or be thrown into space. The entire system would collapse in seconds. All three threats are different, but they share one thing: we cannot stop them. We can only watch and hope. Hope is all we have for now. Space is beautiful and merciless. We are just tiny dots in its vastness, but that's what makes us special. Because despite everything, we keep looking up, always. Black holes are not rare. There may be up to 100 million of them in our galaxy alone. Most are completely invisible. They hide in darkness like cosmic predators, silently. Sometimes a star suddenly disappears. Astronomers see the light go out, and nothing more. A black hole may be responsible. It consumes the star, leaving only a shadow forever. A gamma ray burst may last just 1 second, But in that second, it releases more energy than the sun in billions of years. It burns everything in its path. Atmospheres vanish, planets die, instantly. Rogue planets can be frozen or scorching. Some are covered in toxic gases, others are bare rocks with no atmosphere. And yet, they are a threat, invisible. Now imagine, one such planet approaches us. We wouldn't know until it's too late. It emits no light. It's invisible. And then an orbital anomaly, too late. We rely on technology to protect us, but space is no place for heroism. Sometimes all we have is time and calculations and one wrong prediction, the end. Even our sun can become a threat. In billions of years, it will expand and burn everything around it. Earth will evaporate like a drop of water. Our story will end forever. But we have time, maybe enough to understand the universe better. To protect ourselves and those who come after us, knowledge is our shield, not too late. Every telescope, every mission is a step toward understanding. We search, we observe, we simulate. We learn from each discovery. To one day predict the inevitable and survive. Space isn't evil. It's just indifferent. It gives no warnings and feels no regret, but we are the mind in the darkness. And as long as we exist, we'll search for answers, always. When we look at the night sky, we see the past. Light from distant stars takes millions of years to reach us. Some of them may already be gone. We're staring into the mirror of dead worlds without knowing it. Maybe right now, a new destroyer races through the galaxy. An invisible planet, a black hole, a death beam. We don't hear it, don't see it until it's too late. That's space, no mercy. But fear is no reason to give up. We are the only species that can understand what's going on. We build satellites, telescopes, and stations. We don't hide, we explore. That's power. Each threat is a challenge, each discovery, a chance to survive. We're not powerless, we're just beginning to understand. And the journey is just starting forward. We didn't choose the cosmos, but we can choose how to face it. To look chaos in the eye and not look away. That is the path of reason, the path of humanity. Are we alone in the universe? Or is there life out there, also gazing at the stars? Maybe they fear the dark too, and ask the same questions just like us. We search for signals, we listen to the sky, scanning millions of frequencies in hope of an answer. So far, silence, but silence speaks too, waiting. The more we learn, the smaller we feel. But that's not weakness, it's the beginning of wisdom. We are not the center of the universe, we're part of it. We've come from caves to cosmos, from fire to photons in just millennia, and this is only the beginning. The real future is just starting now. We fear because we're aware. We explore because we seek to understand. That's what makes us who we are. The universe is consciousness, human. The universe isn't hostile, it's simply indifferent. And in that silence, we create meaning. We are the voice in the void. We are alive. Every particle in our bodies came from a star. We are children of ancient explosions, stardust that became aware. We don't just observe the cosmos, we are its continuation, its echo. We dream, and those dreams push us farther. To stars, to discoveries, to new worlds, and maybe to salvation someday. One cosmic strike, and everything could vanish. But that's what makes every moment precious. Every glance at the sky is an act of faith. We live knowing the risk and choose to move forward. We are not immortal, but we leave a trace. In memory, in discoveries, in glowing dots across the sky. And maybe one day, someone will find it and understand. A child looking up through a telescope at night from a small observatory dome, warm interior light contrasting with cold stars outside, face full of curiosity and wonder. Everything must be ultra-realistic, without glitches or unnatural movements. We don't know what lies beyond the horizon. But every mission, every launch is a step into the unknown. We send robots, probes, and ships. And one day, we'll send ourselves forever. They say space is empty, but in that emptiness are billions of stories. Each star, a possible world. And maybe someone's hope or goodbye. When we leave, we send signals, waves that will travel through time and space. Maybe they'll reach someone and become a greeting or a warning. We are the first generation to look into space with awareness. We don't know all the answers yet, but we do know where to look. And we will keep looking as long as we can. We are not just observers. We are storytellers, creators, explorers. And every glance at the sky begins a new chapter, one that no one has ever read except us. Our footprints are not only on the moon. They're in the knowledge we pass on. Each generation climbs higher, reaching closer to the edge where the unknown begins. One day we may leave Earth. Not because we ran, but because we grew. New worlds will become home. But the memory of the first step will stay forever. But as long as we're here, Earth is our only ship. Fragile, alive, precious, and we must protect it. So we don't lose where it all began. Home. Through fear and darkness, we move forward anyway. Because it's in our nature to seek the light. No matter how far it's hidden, we will walk until it shines.